I am Dr. Sureshkumar, Assistant Professor, the Department of Computer Science. I am going to take digital image processing. So, in this digital image processing, there are several topics are available, namely image processing fields, computerized processor types, digital image definition, fundamental steps in digital image, and origin of digital image processing. The image processing fields, it contains computer graphics, image processing, and computer vision. First of all, we would like to see about what is computer graphics. Computer graphics is a field of computer science where creation and manipulation of pictures are carried out with the help of computer, that is called computer graphics. So, which we can be applied in the image processing techniques. That is called the creation of images. And the image processing is nothing but we can say about it is a enhancement or manipulation of the image. So whenever we want to do the add some portions of the image, that is called image enhancement, and we have to manipulate the image. We are handling the images that we can use. There are two types of things we can done in the method of image processing. One is image enhancement and another one image manipulation. And last final one, that is called computer vision. So what is computer vision? It is called as analysis of the image content. So what are the content available in the image that we want to do the analysis? So that is called computer vision. These are the fields it available in the image processing fields. Like we can have that it is here the description. We have the computer graphics where we have used for the AI technique also we can use for the image processing fields. So AI, it is nothing but it is artificial intelligence, which means it is the study of the computer at the time the people can do better. That is called artificial intelligence, which we can use for the image processing technique. So then the image processing is defined as a discipline which the both input and output of a processes or images. And it is used for according to the classification trivial task of computing the average intensity of an image would not be considered on image processing operation. The computerized processors types, which can be, there are three categories we are splitted. One is there is low level processors, that is called input and output or images, and it includes there is task. What is task? It is the primitive operations we have done in the task at the level of low process levels, such as what kind of thing we have done in the low level processes, that is called image processor, to reduce noise, the contrast enhancement and image sharpening. These are the things we have done in the low level processes, that is called image enhancement and image contrast and image sharpening. So there are these three methods we included in the low level processes. And we have the second one, that is called mid-level processes, that we can, it is used for inputs generally or images. Outputs are attributes extracted from those images. Like we can, how we are extracting the images by using edges, contours, then identity of individual objects. And we have that the task. What are the tasks we have carried out at the mid-level processes? The segmentation and description of those objects to reduce them to form suitable for computer processing and classifications. We have done, there are three things in the task under the mid-level processes, that is segmentation, description and classifications. Now we can define as what is segmentation. The segmentation is nothing but it is a partitioning of an image into regions or objects. So and we are getting for the second method, that is description. What is a description? That is objects to reduce them to a form suitable for computer processing. And the final one, that is called as classification, that is called recognition of objects. So which are the images? For example, we can say how can we recognize the images. For example, that is we can use for sports images like animal images. There are some kind of images we could recognize it. That is called the classification. We are classifying the images. And the computerized processes types, that is third type, that is called high level processes. There we can use for the image analysis and computer vision. There are these two ways. The mainly it is adopted with the method of the high level processes. And the next topic heading is digital image definition. So in normally what is digital image? It can be defined as a two-dimensional function that is called x and y. For example, x-y spatial coordinate. The f which is contains that is the amplitude of on any pair of coordinate xy, which is called the intensity or gray level of the image at that point. There we can use for x and y, f for all are finite and discrete quantities. The next one topic is fundamental steps in digital image processing. There we have done, there are 10 steps we are following to do the method of the fundamental steps in digital image processing. What are that? There is first image acquisition, then image enhancement, then image restoration, then color image processing, the wavelets and multi-solution processing, image compression, then morphological processing, segmentation, representation and description, finally the object recognition. We want to see each and every steps we are going to see about briefly now. So one is step 1, that is called image acquisition. So what is that? It is the image is captured by a sensor. For example, we are taking for camera and we can use it for digitalize. If the output of the camera or sensor is not already in digital form, using analog to digital converter we are using, then we are converting. So in simply we could call us, it is a image acquisition is nothing but scaling. Scaling technique, it can be adopted by using the image acquisition. The number 2, that is called image enhancement. The process of manipulating on image so that the result is more suitable than the original for specific application. So the idea behind enhancement technique is to bring out deals that are hidden or simple or highlight certain features of interest in our image. In generally, what is image enhancement is nothing but simply you could describe, we want to add some more portions of the image, that is called the image enhancement. And third one, that is called image restoration. The image restoration is nothing but improving the appearance of an image. Improving the appearance of an image. So there we can use for the mathematical or probabilistic models, we can use for the other hand, that is on human subjective preferences regarding that constitutes a good enhancement result. That is called image restoration. That means we could have that good example for image restoration is nothing but simply you can say about that is the original image it has taken. We want to store again the same image. We want to get it for that. That is called the restoration. So after the enhancement made, then we want to store the same image. That is called image restoration. Once original image has taken, we want to do some enhancement. Then again, we want to back to store on the same image. That is called the image restoration. That is the third step in fundamental steps in digital image processing. And fourth one, that is called color image processing, which can be used for the color of the image to extract features of interest in non-image. That is called color image processing. And fifth one, that is called wavelets, are the foundation of representing images in various degrees of resolution. It is used for image data compression technique. So simply you could describe in the method of wavelet, that is called image compression. How we have done this method of the image compression? Whenever we want to do compressing the image, so what is the advantage by using, once you compress the image, the memory bytes will be automatically saved. That is the main advantage by using the after done image compression technique. So then, the wavelets has the foundation of representing images in various degrees of solution. It is used for image data compression. The sixth method we can use for the image compression technique, which can be used for reducing the storage required to save an image or the bandwidth required to transmit it. The seventh one, that is called morphological processing. That means simply we can say about this method, it is called appearance of the image. So how far we have done this method, tools for extracting image components that are useful in the representation and description of same. In this step, there would be a transition from processes that output images to processes that are output image attributes. The eighth step, that is called image segmentation, which can be used for the segmentation procedures, partition an image into its constituent parts or objects, that is called image segmentation. It is nothing but simply you can say about, it is the partitioning of the image, that is called image segmentation, where we can use for the image segmentation technique, and which is the purpose we are using for the image segmentation. That we can use for the medical images. What is the purpose? Which is the purpose we can use for that? The more accurate the image segmentation and more likely recognition is to succeed on that. And ninth method, that is called image representation and description. The representation is nothing but make a decision whether the data should be represented as a boundary or as a complete region. It is almost always follows the output of a segmentation stage. That means how you are defining under the representation method, boundary representation, region representation. There are two methods we can use. What is that boundary representation? Which can be used for focus on external shape characteristics such as combers and inflexes. And region representation focus on internal properties such as texture or skeletal shape. And step number 9, that is called as representation and description, which can be used for choosing a representation is only part of the solution for transferring raw data into a form suitable for subsequent computer processing. So the description also called feature selection. It is used for deals with extracting attributes that result in some information of interest. The 9th method, that is called recognition and interpretation. Recognition is nothing but the process that assigns label to an object based on the information provided by its description. And we have the knowledge base, that is step number 10. Knowledge about a problem domain is coded into an image processing system in the form of knowledge database. So there we could describe as the overview diagram about there are 10 steps which can be used for the fundamental steps in digital image processing. The next topic is components of an image processing system. It contains 7 components, namely, first one image display, number 2 computer, the third one mass storage, number 4 hard copy, number 5 specialized image processing hardware, number 6 image processing software, and finally image sensors. So everything is connected with the problem domain. Based on that, the problem domain, we can have that we are taking for any problem. We are using the image sensor technique and the specialized image processing hardware. We can apply it and we can use for hard copy of that. And finally, we are using for the image processing software also. We can use. We are going to develop our enhanced images. The first image sensor, about the sensor. 2 elements are required to acquire digital images. The first is the physical device that is sensitive to the energy radiated by the object we wish to image sensor. The second, called as a digitizer, is a device for converting the output of the physical sensing device into digital form. The number 2, it is specialized image processing hardware, which we could be used for that performs primitive operations such as ALU, which performs arithmetic and logical operations in parallel on entire images. The type of hardware sometimes is called as front-end system we can use, and we can use for that the fast data throughputs that the typical main computer cannot handle for that. The number 3, the computer, which can be used one of the component in the for image processing system. It is a system which can be used for the PC to supercomputer in a dedicated applications. Sometimes specifically designed computers are used to achieve a required level of performance. The 4th one, that is called image processing software, which we could be used for specialized modules that perform specific tasks. A well-designed package also includes the capability for the user to write code that is a minimum utilities the specialized modules. And fifth one, there is mass storage capability, which could be used for some image processing applications, where we can use short-term shortage for use during processing, online storage for relatively fast recall. Then third one, that is called archival storage, characterized by infrequent access. So that we can use for the finally archival storage is characterized by massive storage requirements but infrequent need for access. That is the mass storage capability. The sixth component, that is called image display. Once we are using a display any image on the screen, we want to do the display used today are mainly color, preferably flat screen TV monitors, which can be driven by the outputs of the image and graphics display cards that are integral part of a computer. We can use for whenever we want to do a image display. There are two screens we are using. One is the raster scan process and another one random scan process. The raster scan process, which could be used for we are checking the image on that. So we are pixel by pixel we are representing, that is called the raster scan. Whereas in the case of random scan, the directly choosing the image on the output screen. So this one we are doing. There are two techniques we can use for the display monitor. One is random scan, another one raster scan. The final component, that is called the hard copy devices, which could be used for recording images, then include laser printers, then film cameras, then heat sensitive devices, then insert units and digital unit, such as optical and CD-ROM disk. The networking, that is one kind of components which we can be used for the computer system in use today because of the large amount of data inherent in image processing applications, and key consideration in image transmission is bandwidth. So in that case, in dedicated networks, this typically is not a problem, but communications with the remote sites via the internet are not always as efficient. So the last heading, the first unit in digital image processing, that is origin of digital image processing, which could be we are using for, there are several applications we are using for the origin of DIP. The first application where we are used for this, that is digital images in the newspaper industry. These are the method, or these are the eras we can use for the first applications for the origin of digital image processing. The second application, that is called coded pictures, the cable transmission, the reconstructor, the receiving the screen. So that means receiving the display on the image from the screen. So that we can use for the second applications. And third application, that is initial problems in improving the visual quality, in improving the quality of light, early digital pixels, distribution of intensity levels. The intensity is nothing but the brightness of the image. That we can use, we are increasing or decreasing of the brightness of the image. That we are represented and we are referred in the concept of the intensity. The improvement of both tonal quality and resolution. Resolution, which can be we are using for the, it is during the process of the pixel do not overlapping, that we are referred as the concept of the resolution. We can use for the tip used for development of the digital computers. In 1940, who was inventor for that, John Van New introduced for the concept of the DIP. There they introduced, there are several concepts, the camera to hold stored program and data, the conditional branching. There are 7 keys used in DIP. The invention of transistor at Bell Laboratory in the year of 1948. The development in the year of 1980s and 1960s of the high-level programming languages. The invention of IC, that is called integrated circuit. And we have that the fourth one, that is operating system in 1970s. The development of microprocessor, a single consisting of single CPU, memory unit and output control. The introduction by IBM personal computer in 1981. And we have that LSI, that is called large scale integration, late 1970, then VLSI, very large scale integration, and ULSI, ultra large scale integration. The DEPT techniques begin in late 1986 and early 1970 to be used in medical images. For which kind of medical images we can use for that? That is CAT, that is computerized axial tomography, and CT, that is called computerized tomography. So in majorly we are using, and DIP can be used for the medical image purpose they developed. So that, like, what are the images we can use for that? We are taking some different kind of nature images and different kind of some animal images. Like, there are different ways we can using for the DIP. So these are the examples for the digital image processing. And so that is for, it is my final conclusion about that we can use for the, what are the topics we are covered in the unit number 1 under the digital image processing. So there we can use for image processing fields, there we can apply for the computer graphics, there we can use for the image processing and computer vision. So then we have that second one, that is called as computerized process types. There are some kind of process types levels, like what are that, there is first level, low level, there are some kind of levels we can use it. And we can use for that, there is computer vision, it is the analysis of the image content. So these are all the image processing fields, we have done that, and image definition. So there digital image, how to define. So what is the definition for that? We have done that. And fundamental steps in digital image processing, it is a major one under the topic of the digital image processing. All the steps should be followed, and what are the applications we can use for this, each and every step that we are using in the digital image processing concepts. There are 10 steps are available. There is step 1, that is called image acquisition, image enhancement, image restoration, the color image processing, wavelets, the compression, morphological processing, image segmentation, representation and description, and finally that is recognition and interpretation. The next topic, that is it is one kind of conclusion for the components of an image processing. There are several components we can use for an image processing system. So that's all about it. Thank you.